An electric dipole consists of two opposite charges of 5 microcoulomb separated by 4 mm. Calculate the electric field at a point 10 centimeter from the center of the dipole on its axial line here. So here they are talking about the electric dipole consists of two opposite charges. So let me make a mark here, two charges, and it is having a opposite charges. So let me mention here is a negative 5 microcoulombs and this side is a 5 microcoulomb here. Okay, so this is a dipole here. And consider, and the separation between these two charges is how much? That is 4 mm. Okay, now they are asking us to calculate the electric field at a in the axial. So electric field in the axial we are having, that is question mark, that they are asking us to calculate the electric field at a point 10 centimeter from the center of the dipole. So this is the dipole and its center is here. Okay, from its center, okay, from the center of the dipole on its axial line. So this is what x-axis, this is what x-axis. So somewhere we have kept here one test charge. Okay, and the the distance between the test charge and this center of the dipole, which is how much? That is 10 centimeter here. Now we need to calculate how much electric field which is producing on this test charge here. Okay, so for that, this for what we are having formula, that is we are having k 2p over r cube. Here k is a coulomb's constant that we know, that is 9 into 10 raised to the power 9 Newton meter square, and here it is c square multiply 2, and this p, what is p? P is nothing but here dipole moment. So for that we are having formula, that is p, which is equals to product of distance and the charge. So the distance is how much? That is 4 mm. Since it is a millimeter, we need to convert to meter here. So that's why I'm multiplying it by 10 raised to the power -3. It has converted to meter. Now multiply with the charge. What we are having the charge, that is 5 microcoulomb. Since we need to convert to the coulomb, so we have to multiply it by 10 raised to the power -6 coulombs. Okay. Now 5 times 4 is 20. Bases are same, so we can add the power. So I'll be getting -9 coulomb meter. So this value I'm going to write here, that is 20 into 10 raised to the power -9 coulomb meter. Okay, now R. Okay, so that is the distance between the center of the dipole with the test charge, that is 10 centimeter. Since it is in the centimeter, we need to convert to the meter. So I'm going to multiply it by 10 raised to the power -2. Okay, this is R cube, and for the meter also, that is m cube. Now from this m square and this m, it will become m cube. Okay, m cube and this m cube, it will get cancelled, and 1 coulomb, and from this 1 coulomb it will get cancelled here. Now we need to multiply, and before this 10 raised to the power +9 and this -9, it will get cancelled, and we left with the 9 times 2 times 20, that will be getting 360. Now look at the denominator. So this power I'm going to apply for the both. Okay, in that case I'll be having 10 raised to the power 3 into here 2 times 3 will be 6 with the negative sign, and what we left the units here, it is Newton, and in the denominator we left it to the 1 coulomb here. Now in the next step here 360. Now bases are same, powers what we can do, we can add. Since it is having unlike sign, so we need to subtract, so I'll be getting -3 Newton coulomb. Now let me shift to the numerator. I'll be having 360 into 10 raised to the power 3. Okay, Newton coulomb here over coulomb here. Now I'm going to place a decimal point in between 3 and 6, 3.612. Okay, so I need to add here +2, so I'll be getting 10 raised to the power 5 Newton over coulomb. So this is what? Electric field on the axis.